All right, so last time we worked on the sandwich theorem, which means if there's one, I thought I drew it. Damn it.
Hi, Louie. Hi, Daniel.
Yeah, what the hell is this? Like people skipping my class. All right. So if I could have one
That
function
is the
that's always
worst.
going to be above, and if I have one function that'll always be below, the function in the middle is the one I'm interested in. Well, if the top function is approaching zero, right?
Yes.
All right, the limit
Where
is
is
approaching
it?
zero, page 5. And the bottom function,
Oh,
if
wow.
it's,
Wait. Okay.
yeah.
So,
And the
should I
bottom,
not
yeah.
worry about any of this?
Well, I'm doing the screencast and I'll print all the notes for you. So
Gotcha.
you're just going to start where we are.
All right.
So if I say, okay, if the functions are bounding this, if the functions are bounding this, both go to zero, you know the one in the middle goes to zero. It's like a squeeze sandwich theorem. This is the last page of 8.1, so absolute value theorem. Consider a sequence, right? Here's my sequence an. So if the limit as n approaches infinity of a of n, absolute value of a of n. So keep in mind, this means a of n is the sequence, and when I'm talking about the n, that means which one are we talking about? Are we talking about the first term, the second term? Here we're talking about like the millionth term, like as the term number goes to infinity. So this is like the last term in our sequence. But here, if our sequence goes to infinity, our very last term is going to be the infinitieth term, like the nth term. The very last one's the infinity term. Okay, so if the absolute value of that term is zero, then the limit of the sequence as we approach the last term goes to zero. It also can be said, all right, this is a good. It also can be said if the limit as n approaches infinity of a of n, the absolute value does not equal zero. Oh my god, this is so hard to write with. Does not equal zero. No conclusion. Oh yeah, by the way, I am in a wrist brace, so sorry about the bad writing. It's gonna go back to like August levels.
Ooh.
It's gonna be oofy, oof. All right, whatever. Bone hurting juice. Here we go.
So it doesn't equal zero.
So if the absolute value of a of n doesn't equal zero, we can't draw a conclusion. But if the limit of the absolute value of the, nth term goes to zero, then we can say, okay, then the limit will go to zero. So it's just the absolute value theorem. I definitely just like glance in your book. It talks about it a little more. All right, so we can use that here. So we can say the limit as n approaches infinity. I'll go with fine motor skills. -1 to the n plus 1 over n squared plus 2. So let's see. Saying this is saying the same thing as, well, all this like little -1 to the n, that's just flipping the sign every single time. So this guy doesn't actually matter because we're taking absolute value. So this is the same thing as saying the limit of, let's see, as n approaches infinity of n plus 1, oops, ugly, n plus 1 over n squared plus 2. Well,
because it's never going to get anything except one time.
Because this guy is just flipping sign every time. Okay, so here we talked about this already. This is kind of review since you did this last year. Just look at the, what do you call it, leading term? Whatever, look at the exponents, right? Literally, we have an n to the 1 and then an n to the 2 on the bottom. Like, which one's going to win out as we approach infinity? The bottom. As we get infinity on the bottom, this goes to 0. Therefore, the limit as n approaches infinity of -1 to the n plus 1 over n squared plus 2 is going to equal 0. QED, yay, end of lesson. That's it for section 1. Yeah, quit it a little, I don't know, it's some Latin thing. Quit something, it means like done. That's what you'll see in college all the time, QED. It's like when you're doing a proof, it's like, haha, I'm done, QED. Anyway, so that's 8.2, so we're going to get through all of 8.2 tomorrow, Friday, yay, 5-minute screencast.